All right, good evening, all. Good evening, all. How has been our day?
Good evening. Good evening, everyone.
Evening, evening, Miss Loveling.
Good evening.
Good evening.
We're all welcome to our class today. Hope our day has been well. So, we're all welcome, and without wasting much time, if we all agree, I'd like us to start. But if we say we should give some few minutes for those who will be joining us, then we will just wait. So, what say we?
Hey Jacob, I suggest we kick off by let's say 7:10.
Okay. Mr. Jason, are you sharing the same thought?
Yes, sir.
All
Good
right, sir.
evening. Yeah.
Evening, Mr. Jason. Hope your day was fine.
Yes, sir. How about yours?
Was fine too. We give
Thank
God
you.
the glory. All right, so we'll just give like 5 more minutes. By 7:10, we kickstart. Mr. Fraser, you're welcome.
It's Miss Pfizer. Good evening.
Okay, sorry about that. Evening, ma'am. You're welcome.
Thank you.
We have decided to give some few minutes to allow those who will be joining us later. So we are starting by 7:10.
Hello, good evening everyone. Um a quick one. I because we want to keep a track of attendance, so I'll be dropping a link for us to fill in the attendance sheet later. So it's going to be on Google Form. You can just fill and submit. Please, are we here?
Yes, we are. We can hear you.
All right.
All right, everyone. It's 7:10 by my watch, and based on our agreement, I'd like us to start without wasting any other time. We're all welcome to our second lesson on the course Statistics for Economists. Today, our lesson will be looking at introduction to statistics, data, and statistical thinking. Uh, I remain my humble self, the instructor, with Halima Abdulrazak. So, in this course, for this week and next, we're supposed to cover this module. If you have gone through our learning system, uh, the site, you discover that this is part of the courses that we're supposed to cover in this module. The topics we're going to cover in this module, and we have what is statistics, the use of statistics in economics and other social sciences, descriptive and inferential statistics, data sets, numerical measures of position, numerical measures of variability, numerical measures of skewness, numerical measures of relative position, that's for standardized values. Then bivariate data, where we're going to be covering covariance and correlation. Then we have exercises. Nevertheless, Uh, at time intervals, we'll be bringing one or two exercises, especially maybe for every classes. Now, for our today's outline, based on the what we're supposed to cover for this week and next, we have this outline. So first, we're going to have a brief recap of our previous lesson. Then we are going to look at data sets. We'll continue where we stop. Numerical measures of position, numerical measures of variability, and then numerical measures of skewness. All right, in our last class, we looked at what is statistics. We see that most times people think of statistics as just a numerical value. For instance, when we say the gross domestic product of Nigeria, so people think of a particular numerical value. But we say that for this course, we are going to look at a more deeper meaning to statistics, where we say statistics is more like a methodology of collecting data, analyzing data, summarizing data, uh, and presenting data, and all these things. Now, we also talk about the use of statistics in economics and social sciences. We see that in economics, there are a lot of theories, theories of demand, and some other theories, and some also other assertions. But the only thing that will enable us to be able to agree with these theories and work with them is the use of statistics, which will enable us to make some inferential conclusions, and then we are confident that we can make use of this. So we talked about descriptive and inferential statistics. We say descriptive statistics give more or less a description of how the data behaves, how it looks like, uh, whether it's skewed to the left or to the right. Uh, we see that's what descriptive statistics tends to do. I'll also say that the inferential statistics help us to be able to make some inferences regarding some parameters in a given set of data. I would say mostly you use some statistical tools like the t-test, the chi-square, uh, the ANOVA analysis of variance, and some other tools, even with non-parametric test statistics. And from there, we can make inferential conclusions, and then that will give us the enablement to be able to accept some theories and others. So we also talk about data sets, and last time we said that there are about three data sets we make use of in statistics. We say we have the cross-sectional data. We say these data are just collected randomly. They can happen at the same time. Uh, and then we also say that we have the time series data. And this data, the time series data are data that are collected over a period of time. Say from want to know the rainfall statistic or the humidity from 1990, say to 2023. We say that 1990 say to 2023, we say these are time series data because they have been collected over a period of time. Then lastly, we make mention of panel data. We say panel data is a data that has a combination of cross-sectional data and that of time series. Or in other words, they are cross-sectional data that are collected over a period of time. We call them panel data. And we see that we may not make use of them in this particular course, but in econometrics, in the next semester, we'll look at how to analyze panel data and present them statistically. So we also spoke about data sets, and we explained how some data sets look, how we can present them, and we see the method of presentation gives data meaning. So without actually presenting data in the right way, we may not make meaning to this data. So today, we're going to continue from where we stopped, and we will continue from this frequency distribution table. In our last class, we presented some data, and this class, we're going to look at this frequency distribution table, which was gotten from table 1.3, the data in table 1.3 from our last class. So table 1.5 is a more better presentation of the data that we observed in table 1.3. And we can see here, the data has been classified into class. Here, we can see our class intervals, and then we can also see here, we can see the class interval here, and the first class interval we see from 0.0 to 0.5, and under the 0.0 to under that class interval, we see that we have the frequency for male here, which is 1, and then we also have the frequency for female, which is 23. I remember this our data. This class interval represents wages of working class individuals collected in America, and then it represents the wages that they earn weekly. So the total of those who earn wages between 0.0 to 0.5, we have 1 male and 23 female, which gives us a total of 24. Here we have the relative frequency for both male and female. We have a 0.06 for male and a 0.70 for female. And we have a total relative frequency of 0.48. So when we look at this class interval to this point, we can see that for male, we have a total of 17 males in this data. Then we have a total of 33 female, and then a total sample of 50 here. Now, the total relative frequency gives us 1 also for male, it gives us 1 for female, and then when we take them in total, we get 1.0 for all. And here we can see that male here, we have those who earn a wage of 1.0 to 1.5. We have about 4 for male and 0 for female. And then from our last data, we were able to conclude that it is assumed, or it is concluded, that male usually earn more than female. Now, all of the data sets considered thus far are cross-sectional data, like we can see from table 1.6 and 1.7, which present time series data. Now, the first table gives the consumer price. We're going to look at table 1.6 and 1.7 down, but let's just give you a brief description before we go to the data in tables 1.6 and 1.7, which presents us a time series data set. Now, the first table gives the consumer price indexes for 4 countries. That's Canada, the United States, the United Kingdom, and Japan. Now, for the years 1975 to 1996, whereas the second table presents the year-over-year inflation rates for the same period for these same countries. And then we'll we see the formula used to calculate the inflation rates, where pi there denotes the inflation rate, and then P denotes the consumer price index. Here, P subscript T means the current price index.
Please,
While
we are not seeing the screen. No.
we cannot see the screen. Oh, sorry about that.
The stream is little.
So let me work on my network. I think I just lost connection. All right, can we all see the screen now?
We can see it. We can even see it
Yes,
before you went off. We can see it.
Okay, all right.
yes, I can see
Thank
it
you.
now.
All right, sorry, I think my network is having some glitch. All right, so let's go ahead. Just like I was explaining, I'm saying that the table we are going to see below, that's table 1.6 and 1.7, will present to us some time series data sets. And we see that the first data uh, gives the consumer price indexes for 4 countries. That's Canada, the United States, the UK, and Japan. And it gives it for the years 1975 to 1996. Whereas the second table presents the year-over-year inflation rates for the same period for these same countries. And we see that the inflation rate is calculated by this formula here, where pi given by open bracket 100 multiplied by the quantities here. And we say P subscript T means the correct price inflation rate, and then the so P subscript T minus 1 means the inflation rate before the current inflation rate, and we divide also by that same value. All right, in time series data, the elements are units of time. So this distinguish time series data from cross-sectional data sets. We see that the only difference between time series data and cross-sectional data sets is the fact that time series data have elements where the units are time. So they are data collected over a period of time. Whereas a cross-sectional data are data that are just collected maybe just as they are happening without putting time to effect. So a frequent feature of time series data that is not present in cross-sectional data is serial correlation or autocorrelation. As we go on, we will understand what is serial correlation and autocorrelation when we start dealing with time series data proper. So this is table 1.6. We say that it gives us the consumer price indexes for some selected countries. That's from 1980. And then 1970, sorry, that's from 1975 to 1996. And here we're saying that for 1980, they have the same price indexes between Canada, USA, UK, and Japan. So the source for the data is the International Monetary Fund, uh, International Financial Statistics. So here we look at this data. Because it has been collected over a period of time, we call them time series data. We can see the values for Canada for all the various years down through to Japan. Also, this is a time series data for uh, inflation rates for the same selected countries, and it gives the same values, the inflation rate values for all the individual countries. That's Canada down to Japan. Now, let's give some explanation based on the data that we have observed in 1.6 and 1.7. Now, the data in those tables are plotted in figures 1.3 and 1.4. So we look at figures 1.3 and 1.4, and here is figure 1.3, and here is figure 1.4. So we'll come back and look at how we can understand what the graph is talking about here concerning the data that was collected. Is actually descriptive. The graph gives us more like a descriptive of what is actually happening uh, in those countries, or what happened in those countries for those periods of years. Now, you will notice from this plots that one can make a pretty good guess as to what the price level or inflation rate would be in a given year on the basis of the observed price level and inflation rate in previous years. Okay, let's look at the here. okay, this inflation rate for the countries. So we see here, uh, just give me a second. We see here we have the key, which gives us which line is representing Canada, UK, USA, and Japan. We see that the thick lines represents Canada, the dotted lines, but more thicker than the rest, represent USA, and so on and so forth. So, for instance, here, if we want to know the inflation rate for, say, Canada, we want to understand what happened in Canada in the inflation rate in 1985, we can come here and look at the percent per year, and then we can check the year. Here, let's say, for instance, we have 1985. We know that there was about 5% inflation rate here for United Kingdom, and so on and so forth. So here we can be uh, and know, okay, this is the trend to the events uh, that concerns the inflation rate in any particular country. So if prices or inflation are high this year, they will most likely also be high the next year, as we have seen from the graph. Now, successful observations in each series are serially correlated or autocorrelated. That is, they are correlated throughout time and hence not statistically independent of each other. Now, also, figure 1.5 shows a time series that has no autocorrelation. So here we see this is figure 1.5. There is no autocorrelation. We can see the difference between this figure with these other figures. So here there is no autocorrelation, and that's why the graph looks like this. This here we see a time series devoid of autocorrelation. Now, successive observations in each series are serially correlated or autocorrelated. That is, they are correlated throughout time and hence not statistically independent of each other. So, like we said, that figure 1.5 shows us a time series data that has no autocorrelation. Now, we will learn more about correlation and statistical independence later in this chapter when we start talking about time series data. Now, some data sets are both time series and cross-sectional. Like I explained earlier on, I say those data sets that are both time series and cross-sectional, they are called panel data. And we're going to look at them more when we are dealing with econometrics. Now imagine, for example, a data set containing wage and gender data of the sort in table 1.3. Remember, we said that wage is the numerical data, whereas gender is not like not more numeric, not when we're explaining some data sets. So for each of a series of these are called panel data. We will not be working with panel data in this course, but we'll look at them in the second semester course of econometrics. All right, so let's enter to this lesson proper. So let's look at numerical measures of position. We see that there are three types of numerical summary measures that can be used to describe data. And the first of those measures is measures of position or measures of central tendency. Now, the measures of central tendency tells us how the data is concentrated in the middle. That's in the layman language. So if we are interested in knowing the typical rate paid by the firm in question, for instance, we want to know the average weekly pay of maybe male or female, the most appropriate measure to use is the measure of central tendency. And if we want to know the difference between the highest paid and the lowest paid wage weekly, we can employ the use of the range. Or if we want to know the wage that is paid more weekly, which is the mode. So the mean, the median, and the mode are what we call the measures of position or measures of central tendency. Now we also have measures of variability or dispersion. Now, take for instance, we want to know, or we have a question: are all the weekly wages very close to each other, or are they spread out widely? So we employ the measure of variability or disperse. We'll see how they are widespread uh, across the data. And we use mostly the range, the interquartile range, and then the variance, and then the standard deviation. These are measures of dispersion. And then the third measure of numerical summary is the measure of skewness. Let's say we are interested on the information, whether the data is concentrated on one side, the lower level or the higher level. Say we want to know whether those graduates that we were looking at their data from the beginning, whether they are more paid or they are less paid, which are the all the samples that we collected. We want to know whether they are paid more or paid less. We employ the use of the measures of skewness. It tells us whether the data is skewed to the right or skewed to the left. So numerical measures of position. Now the median is a measure of position. In the case of the wage data, for example, that we looked at earlier on in the course, it tells us that half the wages are below 521.50 dollars. If you can remember the, the the data and the tables that we presented, the median that we calculated, we will discover that when we are calculating the range, the upper quartile, the interquartile, and so on and so forth, we remember that the median was $521.50. So it tells us that half are above the wage level, while half are below that median wage level. Now, the mean is another important measure of position in the measures of in the is another important measure of position. So more precisely, the arithmetic mean, commonly known as the average value. So the mean of set of numbers are x1, x2, x3 to xn. Sorry, this one they are supposed to be subscript. I think is a typographical error. So this is supposed to be x subscript 1, s subscript 2, x subscript 3, up to x subscript n. So we're trying to say these are individual values in all the sample. So the mean of these numbers is given by this x bar, this measure x bar. Now x bar gives us the sum from I ranging from 1 to n of all the xi's, and the xi's are the x1 to xn. So we sum all the individual xi's and we divide by n, which is the total number, and that gives us the arithmetic mean, where x bar here is the arithmetic mean, and summation I ranging from 1 to n here of all the xi's is the sum of all the individual x's or individual values in the observation. Now, the sum of the weekly wage data, including both for males and females, is $30,364. That's if we sum all the individuals, like this summation, I range from 1 to n of all the exercise. If we sum them, we have this particular value here, which is the total. And then the mean is $607.28. That's if we divide it by the total number of observations that we have, we will get this value. So the mean wages of males and females respectively, that's if we calculate them separately, we get this value here for males, and then the value here $424.42 for females. Now it follows from equation 1. Here we see our equation 1 here. These are equation 1, and then these are equation 2. And from equation 1, we see that the sum of the observations on a particular quantitative variable in the data set is equal to the mean times the number of items. That is equal to the mean times the number of items. So mathematically, what we did here was to cross multiply. So if we cross multiply the mean here with n, and then this with 1 here, we will discover that the sum of all the observations is equal to the mean times the number of items, as we can observe here. And that the sum of the deviations of the observations from their mean is 0. So when we take the sum of all the deviations. Unless we take individual values, we subtract from the mean, we take individual values, we subtract from the mean, and then we sum everything, we will get 0. Yes, so if we do that, maybe at your leisure, you can try that. You will get 0. You take, for instance, our example on wages, weekly wages. We can take that with the mean, subtract them, and sum everything. We will get 0. When a set of items is divided into classes, as must be done to create a frequency distribution, the overall mean is a weighted average of the means of the observations in the classes, with the weights being the number or the frequency of items in the respective classes. And when they are k classes, then we have this particular formula. The mean gives us the frequency times the particular class. So each observation multiplied by its frequency, and then we sum everything. So we get another representation here for the arithmetic mean. So, like we explained here, we say when a set of items is divided into classes, then we cannot employ the formula in equation 1 for the mean, but we will adopt this formula in 1.5 to get the mean. So where x bar I, as usual, is the mean of the observations in the ith class, and f subscript I is the number of frequency of the observations in the ith class. And if all that is known is the frequency in each class with no measure of the mean of the observations in the classes available, we can obtain a useful approximation to the mean of the data set using the midpoints of the classes in the above formula. So we can also have an alternative value for the mean, which we call the geometric mean. Now, this geometric mean is the antilog of the arithmetic mean. So when we do that, we get what is called the geometric mean. Yeah, so we have this representation here, or the nth root of all the observations. So when we place a bar on top of a variable to note its mean, as in x, so when we have uh, this here, and then we place a bar on top, it usually used to represent the mean of samples. But when we use this Greek alphabet mu here, is used to represent the mean of a population. I've explained earlier on that we get from a population, because it is usually not possible to make experiment with all the population, we say that we use samples. So once we are calculating the mean of sample, we use x bar here to represent the mean of samples. Whereas if we are trying to get the mean of the population, we use the Greek alphabet mu here as a cycle to represent the mean. Now, when the population is finite, that is, the population is countable, mu can be obtained by making the calculation in equation 1.1, like we've shown, using all the elements in the population. Whereas the mean of an infinite population, that's when the population cannot be, it's not countable, maybe it's not possible for us to know the whole true value. By a process is derived from the mathematical representation of that process. Now, in most practical cases, this mathematical data generating process is unknown. The ease of obtaining the means of finite as opposed to infinite population is more apparent than real. Now, another measure of position is the mode. So the mode is defined as the most frequently appearing value. So when we have an observation and we have the observation that has the most frequently appearing value, it gives us the mode. Now, when the variable is divided into equal sized classes and presented as a histogram or frequency distribution, the class containing the most observation is called the modal class. Let's say we have a histogram. Let me see what I can see. A histogram. All right. So here in the second figure, we see an histogram, and then we see the bar that has the highest height. So here, this bar is telling us that that's the mode of the observations. Now, secondly, a histogram that has two peaks, let's say it has two high values, we call that kind of histogram bimodal. Whereas, as in example, sorry, figure 1 here, we see that it has two peak, so we call it bimodal. This graph here, we have a peak here, and then we have another peak here, high occurrence. So we call them bimodal. Whereas this second observation, it has only a peak, one high peak of the histogram. So this is unimodal, which means it has one mode. So it's possible for an observation to have two modes. A frequent example is the performance of students on mathematics and sometimes statistics texts, where the students divide that into two groups, those who understand what is going on and those who do not. So given that there's a variability within each group, there will typically be two humps in the histogram, one at a high grade containing students who understand the material, and one at a low grade which contains students who do not understand the material. So we see on both the histogram we have two peak. So that gives us a bimodal. Now we can also imagine the horizontal scales are representing the grade achieved on a mathematics test. So just like I explained earlier on with these two histogram, the first one gives us a bimodal data, and then the second one gives us a unimodal or humped shape distribution. Now, the second measure, the first measure we talked about was measure of position and or central tendency, and then the second measure is numerical measure of variability or dispersion. Now, the range and interquartile range measures variability, and also the variance and standard deviation also measures the dispersion and variability. So the variance is broadly the mean or average of the squared deviations of the observations from their mean. So when we get the sum of the squared deviations from their mean, it gives us the variance. Now, for data sets that constitute samples from populations or processes, the calculation is given by this formula that we have here. So when we see S squared as it is here, it represents the variance. So we see that for a sample from population, we use this particular formula here, summation I ranging from 1 to n of all the xi's, the division from the individual values from that of the mean when we square the sums of deviation divided by n minus 1. So here n minus 1 gives us the variance for the sample. So here S squared denotes the sample variance, and an approximation can be calculated from the frequency distribution of the sample, using this same formula. So if we want to get an approximation of the sample variance, we can also use the formula in 1.7 to get that. So here, S is the number of classes, F subscript I is the frequency of the ith class, and X bar I is the mean of the ith class. So like remember, we said that X bar is the mean of the whole sample. And we say X bar stands for sample mean, where mu, the Greek alphabet mu, stands for the population mean. So whereas this value here stands for the total number of elements in the samples. So we either use n here, or we use summation. We use n here, or we use summation I ranging from 1 to s of all the fi's. So we sum each individual frequencies, just like we have explained earlier on. The population variance is denoted by sigma squared. Remember, we say that the sample variance is denoted by S squared, whereas the population variance is denoted by sigma squared, as we can see here. Now, for a finite population, it can be calculated using the formula in 1.6, where we replace n minus 1 in the denominator by n. So for the population variance, instead of using n minus 1, we will use n. Whereas for the sample variance, we use n minus 1. Those will give us the formula for the sample variance and the population variance respectively. Now, the population mean, on the other hand, is a fixed number which does not change from sample to sample, while the sample mean changes from sample to sample, which means if you take the mean of the whole population, it remains the same, constant. Whereas if you are taking the mean of individual samples, they vary one to another. For each sample you take, you get a different mean, even though they are coming from the same population. Now, uh, let's use our example on weekly wages to explain the measures of variability from the example that we have above. Now, in the weekly wage data above, the variance we can take our time to check the data again. Uh, if going back there will maybe scatter our the flow. So maybe when we get time, we can check the weekly data again so that we will be able to lay them side by side and understand our explanation of measures of the variance here. Now, in the weekly data above that we use, that we have been using from the beginning of the course, the variance of the wages is 20716.15 for males, and then 42898.7 for female, and then 161893.7 for the entire sample. Now, if you notice, you notice that the units in which these variances are measured is dollar squared. So we are taking the sum of the squared dollar differences of each person's weight from the mean. So to obtain a measure of variability measured in dollars rather than dollar squared, we can take the square root of the variances in equation 1.6. This is called the standard deviation. So these are formula of variance in 1.6 and 1.7. When we take the square root of this formula, just like what we explained, it gives us the standard deviation. So the difference between the variance and the standard deviation is, whereas the variance is the square of the deviation, the square of the deviations from the mean, the uh, standard deviation is the square root of the variance. Sorry. All right. So the standard deviation of wages in the above sample, when we take the square root of the variance, we get the value $455.15 for males, and then $207.12 for females. And then for the entire population, we get a standard deviation of 402.36 for the entire population. Now, another frequently used measures of variability is the coefficient of variation. So it is defined as the standard deviation taken as a percentage of the mean. So this formula here gives us the value for the coefficient of variation. So where C denotes the coefficient of variation for the weekly wage data. For the weekly wage data above, the coefficient of variation is 47.30 for female, for 30 for males, 48.8 for females, and 66.28 for the entire sample. Now, the third uh, numerical measure that we talk about is the measures of skewness. Now, skewed quantitative data are data for which a frequency distribution based on equal classes is not symmetrical. What do we mean by that? We mean that it's difficult to have a data set that is symmetrical. Symmetrical means that it is balanced on both sides. Usually it's difficult, but just like the normal distribution that assumes just the normal distribution that is symmetrical, where every other distribution is either skewed to the right or skewed to the left or thereabout, or experience kurtosis. Now, we say that for skewed quantity data are data for which a frequency distribution based on equal classes is not symmetrical. It's not symmetrical. So, for example, the wage data presented in figure 1.1 are not symmetrical. Why? Because the right tail is longer than the left tail. What does that mean? What do we mean by that? We discover that male are paid higher than female. So that is why it is not symmetrical. And that's why we see that the right tail is longer than the left tail. So which is non-existent in the bottom panel. So these data are described as skewed right or skewed to the right. So any data in which the direction of the longer tail is to the right, we say that this data is skewed to the right. Whereas if the direction of the longer tail is to the left, we see that the data is skewed to the left. Now, when the skew is to the left, the mean will be below the median, and the median will be below the mode. Now, the rightward or leftward skew is due to the influence of the rather few unusually high or low values. So, in an observation of data, if we have a situation whereby there's a high data or there's a low data, we will get the effect of skewness. So it will either be if the data is high, very very high, let's say maybe to the right, then the data will be skewed uh, to the right. Take for instance our data here that we discover that male receive higher wages than female based on that experiment and the data that was collected. So we see that that data is skewed to one side. It is not symmetrical. Now, when the data are symmetrically distributed, the mean, the median, and mode are all equal. So when the mean, the median, and mode are all equal, we say that data is symmetrical. For instance, it is from our data that we discovered that the median was 521 point something. If the mean and the mode are also almost the same value or the same, we say that that data is symmetrical. And that is what the normal distribution assumes. It assumes that everything is normally distributed. As we go deep into the course, we will understand some of these terminologies more and more. And we'll see how we can use data sets to understand some of these um, statistical measures. Now, summary. So, today we explain data sets, and then from our last class, we see that three data sets are usually being used in statistics, and we see that these are the cross-sectional data, the time series data, and then the panel data. The cross-sectional data, we see they are data collected just uh, just randomly, not taking note of time. And then we see the time series data are data that are taken with a unit, and the unit there is time over a period of time. And then we see that the panel data are data that has both the characteristics of the cross-sectional data and that of time series data. Now we also explain how to present some data sets. We use the frequency table to see how we can make more meaning to data sets and get more information and get more understand how the behavior of this data. Now we explain the numerical measures of position. We see that in statistics we have basically three measures of position, which are the measures of we have three measures, numerical measures, sorry, and we see that we have the numerical measures of position or the measure of central tendency. We see that helps us to see whether how concentrated the data is in the middle. And we see that the mean, the median, and the mode are the statistical measures that help us, or statistical parameters that help us to measure this position or central tendency. We also talk about numerical measures of variability or dispersion. We say if we want to know how widespread a particular data is, the measure of variability helps us to do that. We see that the range, which is the value of the highest minus the lowest, the interquartile range, the variance, whether sample variance or population variance, and then the standard deviation, the coefficient of variation are the particular measures of variability that we can use to get how dispersed the data is. Now, we also talk about numerical measures of skewness. We say some data may be due to high values or extreme low values makes the data to be concentrated on one side, either to the left or to the right. I would say the data that has a longer tail to the right is called skewed to the right, whereas a data set that has a longer tail to the left, we say it is skewed to the left. So these are our exercises. But before then, I would like to open the room for questions. So if we have questions, I would like the class to be interactive, just like we say. If you have questions, please you can. The floor is open. I want to believe that you have been with me until now. Yeah, hello, are we there? This is Faisal. Any question? Mr.
Hello,
Jason.
sir.
Okay,
So please, I want to find out concerning the panel data.
data,
You
yes,
know, you
ma'am.
talked about series, yes, and panel. I don't know if you can show more, like, 'cause you say you're not going to talk about it, but I don't know where can panel data come up, if possible. You know, the cross-sectional, the what do you call the other one?
The time series data.
Yes, the panel. Yes, where is it possible that we can have panel data when we are talking about public policy?
Okay. Uh, the the panel data, just like I explained, uh, when we have data that has the characteristics of a cross-sectional data and that of time series data, we call them panel data. Now, in public policy, uh, let's say we're interested in maybe the GDP of Nigeria, let's say for a particular time from, uh, or like let's say maybe a minister of maybe minister of the economy, for instance, and we want to understand the maybe the exchange rate for some particular year, and then we have some other parameters that are not okay. Let's say exchange rate, and then we I don't know whether you're following. Are you following?
Yes, I'm following you.
Okay. Okay. I think what I will do is I will look for a more appropriate panel data when we come in the next class. I will uh, shed more light on it. Is that okay?
Yes, that'll be very fine. Thank you.
All right, you're welcome. Any other questions?
Yeah, good evening, everybody here.
Evening, Mr. Abaka.
It's not Abaka, it's Abakba.
Okay,
What you
Abaka.
call me?
Okay, sorry
What you
about that.
call me?
All
Yeah.
right.
So, unfortunately for me, yesterday and today, I've been on the road trying to get back to work from home from work
Okay.
because I have a retreat in my office, and this class the yesterday class and today class. Unfortunately for me, I missed them. And I
Okay.
don't know whether the videos that you guys will say will share with us will do the justice to help me to gain what I've lost in these 2 days. I just pray so. I want to ask, I saw the videos of the other classes. I don't know, is there any way one can download those videos, or I'm meant to go through it online? I don't know how one can just, download it into one's system so that you can, I mean, go through it gradually, bit by bit, instead of rushing through online. Is there any way one can download it?
Okay. Yeah, I think you should be able to access them in the Google Drive. There's a link to a particular drive that was sent to the main WhatsApp page. If you can locate it and log in, I'm sure you can
Yeah.
see the video there and download it.
Yeah, that's what I'm saying. That is it possible for one to download the videos instead of, going through it online? Is it possible to download it through the link that was shared?
I think it's possible. Have you tried downloading it?
I tried, it wasn't possible. I tried, there was nowhere to click to download it. I don't know whether I should copy the link into another app to download. I don't know. But
All right.
anyway, that's the problem. I'll try to do that.
Okay. All right. If that's the case, we'll look at it and then we'll get back to you.
It's all right. All right, thank you.
You're welcome. So, any other questions? All right.
Yeah, no problem.
Okay. Yeah, I'm getting you. Right.
Okay, so is there any way we can use advanced Excel to do this analysis, all this data? Will you be taught the functions? No, I'm sure these functions are in advanced Excel, where we can use it to analyze all these data, put it in our pivot table, and be able to get, be able to get, what I say, we can be able to present it, for maybe actual jobs that we do, or maybe for maybe you're writing a topic, or you're writing on a paper. Can we really use advanced Excel to do all these calculations, this analysis?
Yes, you can. There are a lot of softwares that you use for this analysis, like Advanced
Because
Excel,
I heard
the
you
Easy.
mention econometrics. I'm used to econometrics in doing all these things, especially time series. I'm used to econometrics. We were taught with econometrics in University of Abuja in my masters, you know.
Okay.
So I don't really
Mm.
know if advanced Excel can also do all this. I know there are a lot of functions in it, but can you expose us to it during the course of this training?
Yes, we will. We will. There are those who will be teaching. I think. I think Python. I'm not sure if it's taught in this particular class, but I think there's someone who is teaching Python, R, and some other softwares. But as time goes on, when we are bringing some examples, we will employ some of these softwares and see how we can teach it here, like the eViews, the Stata, uh, and others are, especially when you are about doing the research. I'm sure you must have gone through all the uh, the all the all you are going to do in the course entirely. We have the first semester, the second semester, and then the research semester. So during those periods, you'll be taught how to use some of those softwares very practically.
Okay, that'll be good, sir. Thank you very
Yeah,
much.
you're welcome. So do we have more questions? All right. So these are our exercises which will be presented in our next class. So I believe everyone can see them. we have from 1 to 4. The first exercise says calculate the variance and standard deviation for the samples where these particular values are given. So based on the formulas that we have given in at the course of the lesson, we can employ them to solve number one. And then there's a hint there. You can modify equation 1.6 by expanding the numerator to put in an equivalent formula for the sample variance. So when you use them, we can get what we're looking for, the standard variance and standard deviation for these particular values from A to C. Now, secondly, we will explain how the relationship between the mean and the median provides information about the symmetry or skewness of the data's distribution. Then also, we will uh, uh, number 3 says, what is the primary disadvantage of using the range rather than the variance to compare the variability of two data sets? Remember, the range and the variance are two measures of variability or dispersion. So uh, we should make a research to know the primary disadvantage of using the range rather than the variance. Then finally, we will know, can the standard deviation of a variable be negative? So we will answer all these and present them as in the next class. Remember uh, that our attendance to lectures, our exercises, and then the tests and the exams all form part of our continuous assessment. So it is very, very important and necessary for us to do these exercises. We'll give us some time. Everyone will present his own result in the next class. And then we'll also see how we can do some of the tutorials and more of the questions. We'll answer, we'll bring
Are
more
you dropping this
questions.
on the WhatsApp platform? Are you dropping
Yes,
these questions on the WhatsApp platform?
yeah, we'll drop them on the WhatsApp platform. And then
Okay.
also the material will be uploaded in the drive so we can access it there.
Okay. Did you put an individual drive for everybody or just one drive?
There's one drive for everyone. You have you accessed the drive before?
Yes, there was a time I did project management, digital project management last year, but we all had the individual drive, so but they would just send everything to your individual drive. So I don't know this one of a single drive. I don't know if I'll be able to. Well, anyhow, if you teach us how to go about it, then I'll be able to know what to do.
Okay, it's actually not difficult to locate the drive. There's a link to the drive that is always sent in the main WhatsApp page. So once you go there, uh, I'll let them know that they should send the link, resend the link again. So you can just tap
Okay,
in and log in and
okay,
you
okay,
can access it. Yes.
okay, sir. That would be good, please. Let them send it again.
All
Although I
right.
saw it this afternoon. Though.
Okay. All right. So, Alima, can we hear from you?
Okay, it's concerning Chuma's seminar. I think he's supposed to address the class from 8:20. Can you hear me?
Yeah, we can hear you. I
Okay.
don't know
I
if the
said
others can hear.
okay. So the seminar instructor is supposed to address us from 8:20. So we'll wait for him by then. Please, are we okay with that?
Oh, yes, we are okay. We are waiting. This is
Oh,
11:20.
all right, thank you. Hello, Chuma, are you here?
Yeah, I am. Thank you.
Okay.
Good evening, everyone. So we'll be starting in a couple of minutes. It will just be a brief session during which we'll briefly discuss the paper that the presenters will be presenting on next week. Then also the assignments that will be based on the paper will be shared. So everything will be explained before the end of this brief session. Thank you.